Here in Chapter 11, we're going to take a topic that you studied a little bit in Algebra 1, quadratic equations and quadratic functions, and we're going to extend it pretty far. We're going to make an entire chapter out of it. So the first thing we need to do is we need to develop a technique that will allow us to solve quadratic equations that can't be factored. That was the main technique you learned in Algebra 1, and for some of you, that might have been the only technique you learned in Algebra 1. Maybe all you know is to set it equal to 0 and factor. But there are a couple of other techniques, and factoring does give you easy answers, but these other techniques, these can give you answers even when the thing doesn't factor. Like if you take a look at these two examples here, neither one of these is going to factor. It should be pretty obvious pretty quickly that you can't factor either one of these. You're welcome to try, but they're not going to factor. But they're still very easy to solve if you just take a different approach. The different approach here is to isolate the squared part. Like in this case, we're going to move the 5 over and divide by the 6, and then take a square root. So technically, that's a new step. Take a square root is not something that we've done before, but I bet it feels instinctive. I mean, most of algebra, when you're solving equations, it's almost always do something on both sides of the equation. Well, same idea here. We're going to take a square root. So the square root of x squared is x, and the square root of 5/6 is going to require a lot of simplification. And then there's one kind of important technicality. When you take a square root, and we talked about this back when we were doing our chapter on roots, there's really two answers. There's a positive number that when you square it will give you this, and then there's also a negative number. So whenever you do a take a square root step, always remember there should be two answers, a positive one and a negative one. And the easiest way to do this, rather than writing them out as two equations, is just put plus minus in the front. It's very quick and easy, just don't forget about it. Now, this still needs to be simplified because square root of 5/6, that technically has a square root in the denominator, and that's not okay. We're not allowed to have square roots in denominators. Luckily, simplifying our denominator here is much easier than it could have been. Since we just have a single square root in the denominator, all we have to do is multiply top and bottom by another square root of 6. Square root of 6 times square root of 6, square root of 36. Our denominator is just 6. And in the numerator, square root of 5 times square root of 6 is square root of 30. So that wasn't really very hard. That's a fairly straightforward technique to use. Take a square root, the square root method. We can use it over here in this other equation. We isolate the square, and then take a square root. Don't forget you get plus or minus. And we have to use the stuff that we just learned at the end of Chapter 10. We learned about the square roots and negatives are no longer the end of a problem. This means now you're going to be using complex numbers. And I kind of warned you about that. I said that was sort of why we learned complex numbers, was so that we could deal with quadratic equations that give you square roots and negatives. So here, the negative splits out as its own separate little piece. Negative 4 is negative 1 times 4. And we know now, because of the end of Chapter 10, we know that the square root of negative 1 is I. Oh, wait a sec. Square root of 4. Well, that's not legal. Of course, you got to take the square root of 4. The square root of 4 is 2. So I times 2, just like x times 2, you would say 2x. Here, I times 2, you say 2i. So you're looking at these two examples here, and you're thinking, wow, this is pretty easy. This square root method is really simple. Isolate the squared term, take a root, and you're good to go. Well, it's not quite that simple, and that's really what we're going to have to spend our time on here in 11.1, is learning to do the tough cases of making this thing fit. So I'm going to start with an easy example, and then I'll do a medium example, and I'll sort of ratchet up the difficulty a little bit at a time and show you each little complication as it can occur. Here, if you just isolated the squared term, you would have a variable on the other side. You would have t squared equals negative 8t plus 3, and then when you take a square root, you're not really solving this equation because you've got variables on both sides. That's not okay. So that's not what we do here. Instead, what we have to do is try to make this problem look kind of like the earlier ones, where we had just a single thing squared equals a number. Single thing squared equals a number. Here we want to have a single thing squared. So something squared equals a number on the other side. Here's how we're going to get there. Here's what it's going to take to get to that type of setup. First, move any number parts, anything without variables, over to the other side. And then you're going to put some magic number here. You're going to add something to both sides of the equation. You're going to go plus something on both sides. And the real trick to completing the square, sort of the magic machine that makes it run, is what do you add? What do you add to both sides? And we'll eventually get down to a pretty simple technique. But the idea is, whatever you add there, we're trying to create something that will factor into something like that. And because of how this polynomial starts, I know the factoring is going to have t, and it's going to have to be plus something. And then you're kind of doing guess and check. It's not really guess and check because you can guess smart and you can not waste your time with bad guesses. Like, there's no way this is 47, right? There's no way you square that out, it's going to give you an 8. And if you guess and check just a little bit, you'll very quickly realize that the number that has to be there has got to be a 4, so that you'll end up with an 8. If you're not sure why that is, just think for a second. What happens when you go t plus 4 times t plus 4? And you FOIL it out. Well, you get t squared, and you get 4t, and you get another 4t. And then this part's really important. What do you get at the end? You get 16. That's the thing we have to add to both sides so that this will factor into that. So you kind of jump forward into what it should factor into, and then you back up to what does it take to make that thing fit. It's a weird process. It's a little zigzag. You go forward and then back. But once you've gone forward and back, then it's fairly easy. Then you just take a square root. So now you have t plus 4 equals plus or minus the square root of 19. And of course, t plus 4, that's not fully solved. You got to subtract 4. So you end up with t equals negative 4 plus or minus square root of 19. And there's no way we could have gotten that answer by trying to factor it. This polynomial doesn't factor at all, not even close. But still, we're able to get an answer here, and if you grab a calculator, you can even get a decimal form for it. Most of what we have to do, though, is to deal with trickier cases than this one. Once you practice completing the square and you finish the homework for 11.1, you're going to look back and realize this was a really easy problem. They're usually a lot harder than this. So let's crank it up a little bit. Let's see what one of the complications is. Here's a slightly harder one. The thing that's difficult about this is that coefficient in the front. And the reason why that's difficult is if you think back to when you were learning factoring, factoring is so much harder when there's a leading coefficient in the front. I mean, it's like a dramatic increase in difficulty level. And it's such an important deal here in completing the square that we absolutely cannot have that 4. So what we do at the very first step is if there's a leading coefficient in the front, divide by it. Divide the entire expression by 4. So now we've got just k squared, which, oh, sense of relief, that's going to be much easier to factor. And we're going to have a 2k here. And then you see this part, you say, ah, dang it, I divided by 4. I've got 5/4 now. And yes, I know that's a fraction, and yes, I know you're feeling very uncomfortable about that, but unfortunately, there's really no better option. You just kind of have to live with the fraction and just deal with it. Once you get rid of that coefficient in the front, then we proceed the way we did the easy example a second ago. Move the number over to the other side. In this case, the number is indeed a fraction. Yes, it is. And then figure out what you have to add to both sides in order to produce something that'll be a parentheses squared. So I know it's going to have a k. Not having a coefficient in the front makes that part really easy. Plus, and think about foiling this out, it's going to have to be a 1 there. I bet you're already inventing a shortcut. I bet you're thinking about the problem we did a second ago, where the 8, we added 4, and you're looking at this one, 2, we're adding 1, and I bet you're inventing a shortcut. And then imagine squaring this out. What number would be at the end? That number would be 1. So, there's a little bit of fraction arithmetic you have to do. Over here on the right-hand side, you've got to go -5/4 plus 1, which means, yes, you have to get a common denominator. But this is Algebra 2. You really can't whine about doing fraction arithmetic anymore. You've got to be past that at this point. All those years of practice in math classes where you were supposed to be learning how to work with fractions, you were supposed to be learning how to work with fractions. No kidding. You need to be able to work those problems with competence. Once you have your equation looking like this, something squared on one side equals a number on the other side, then you take a square root. So you're going to have k plus 1 on the left and the square root of -1/4 on the right. Don't forget, plus or minus. Now this is actually a lot easier than it looks like over there on the right. They're probably panicking a little bit, but it's actually not so bad. First of all, square root of a negative, that means we're going to get I. And the square root of a fraction, square root of 1 is 1, square root of 4 is 2. That's actually not such a bad thing. And one final step, get k by itself by moving the 1 to the other side. And yeah, that's typically what your answers to these problems look like. They're not clean little 5 or 18, they're not nice little whole numbers. They tend to be complicated things involving fractions or roots, or like in this case, fractions and complex numbers. Your answers tend to be fairly complicated looking things, so it doesn't mean you've made a mistake if your answer comes out a mess like that. It's kind of expected. Okay, so that's a harder problem clearly, but you'll see I've labeled it as medium. There's still harder things to look at. So here's a tougher problem. And it doesn't look tougher at first. You look at the front there and you go, oh, I don't have to divide by anything. Thank goodness, no fractions. And I can go right to move the number to the other side, and that's not so bad. I just move a 2 over to the other side. But then you get to the figure out what you have to add on both sides part. And here's where it gets to be a bit of a mess. The shortcut that you were probably inventing earlier was probably something like, cut this number in half. But it's an odd number. Well, unfortunately, oh well. It's just too bad. It's an odd number and you still got to cut it in half. So cut it in half is the right shortcut. If you were inventing that in your head, you did invent the right shortcut. It just has some side effects that you're not particularly happy about. Here, cut it in half means cut it in half. Divide by 2. The number that's going to be there is going to be 5/2. Then, the other part was to figure out what number goes there. And if you think about foiling this out, and I know you don't want to, but maybe you should take some scratch paper and try foiling it out, the number you would get when you foil that out is going to be that thing squared. So the second part of the shortcut is first cut it in half and then square it, which in this case gives you a mess. So you thought you weren't going to get fractions in this case, and you were so wrong. There's totally fractions in this case. Really messy fractions. And then on this side, you've got to get a common denominator and combine those together. And let's see, 4, so it'll be -8/4, and 25, you're going to get 17/4. And then take your square root. So you're going to have a plus 5/2 equals, don't forget your plus or minus. It's probably a good idea to just automatically write it. You don't even think about it or fill it in later. You do that part first. And then we've got square root of 17/4. To finish solving for a, you move the 5/2 to the other side. And while we're at it, remember, that's technically square root of 4 in the denominator, and square root of 4, come on now, that should be 2 for sure. The other thing is we sort of have an opportunity here, and this comes up much more often than you would think. These have a common denominator. They're both 2. So you could even more simplify the answer by making a single fraction out of it. And that is indeed what we expect you to do. We expect you to take the 2 fractions when they have a common denominator, or even if they don't, make them have a common denominator then, and put the 2 fractions into a single fraction. We have one last example to do, and this is a pretty big one. But this is important for us to be able to handle what happens in section 11.2. So this is the toughest sort of a problem. You're probably going to want to pause the video several times as I go through this and try working out things on your own, because following through this one is really where you learn how completing the square works in its biggest, most complicated setting. So, we have a leading coefficient. We have to start by dividing by that, and that already goes badly in this problem. Divide everything by 3, and the only part that comes out nice is the z squared in the front. Here, 7 divided by 3 is not particularly nice. 5 divided by 3 isn't any nicer. So we're getting fractions right from the very first step. Next, take the 5 over 3, move it to the other side. Just like usual, move whatever constant you've got over to the other side. And then we're trying to create something parentheses squared equals a number. And the steps are, and I'll remind you, the first step is cut in half. If you're taking 7/3 and you're, quote, cutting it in half, it might be easier. You might have an easier time doing the arithmetic if you cut it in half by multiplying by a half, because multiplying fractions is easier than dividing. And you'll see pretty quickly that what you're going to get when you cut that in half is you're going to get 7 over 6. So that's one step. Then the next step is square it. And yeah, that goes really ugly. 7 squared is 49. 6 squared is 36. So you get 49 over 36. Oh man, what a messy fraction, huh? And then you got to put those 2 fractions together, which means you got to get a common denominator, which in this case is going to be 36, and you're going to have to add the numerators together. When you're all done, you're going to have negative 11 over 36 there, because you multiply top and bottom by 12, 60, negative 60 plus 49, you get negative 11 over 36. Then you take your square root. Don't forget plus or minus. And with this square root, once you really understand how to work with square roots with fractions, you'll realize there are actually kind of 3 square roots going on in there. One of the square roots is square root of a negative. So square root of a negative, we know what that does. That gives us I. In the numerator, we have square root of 11, which is not a particularly nice thing. But in the denominator, we've got square root of 36, which is pretty good. That's 6. And then we move the 7 over 6 to the other side. This is a complex number. It has I in it. So although you have a common denominator, and it would be really tempting to make a single fraction out of that, that common denominator sort of pulling you in that direction, because of I, you have to leave it in standard form for complex numbers. So this is the correct answer for this. That's the way you're supposed to write it. A plus BI form. So make sure when you're done with problems like this, you've got them in the right form. The computer will usually correct you if you're in the wrong form, but one time or another you're going to have to write this on paper. So on paper, make sure you write these things in the right form. What we're going to be doing next time in 11.2 is we're going to be doing a problem very similar to this one here, except we're going to be using it to create something called the quadratic formula. You may have heard of the quadratic formula before. But what we're going to do here in Algebra 2 is we're going to show you where it comes from and why it works.